Okay, part 2, guys. Let's review a little bit from what we did yesterday. What are my 6 trig functions? Their ratios. Sine theta is y over r. Good. Cosine theta. X over r. Tangent theta. Good job. Now we're going to do our reciprocals. What's the reciprocal of sine? Cosecant. Fantastic. What's the ratio? R over y. Perfect. So then I have secant of theta is r over x. Good. And then I have cotangent of theta is what? X over y. Okay. What do we know? R is always positive. Good. What's the little formula we use if we have x and y and we need to find r? Or we have x and r, we need to find y? X squared plus y squared equals r squared. And r is always positive. That's our hypotenuse. All right. All we're doing is transitioning from SOHCAHTOA to our little ratios here. So let's go to the first slide. This is not anything you guys have to memorize up here, right? This is just explaining to you when things are valid, when they're not. Sometimes you're going to use your calculator and you're going to get an error message. You're going to find, thank you, that like you plug in sine of something and it comes out error. That means it's just less than -1 or it's greater than 1. All of these things, again, you don't have to memorize right here. It's just to show you that there's intervals where some things don't exist, and that's okay. Switch. What these are called down here is the Pythagorean identities. Why do you think these are called the Pythagorean identities?
Because it's about the legs and the hypotenuse.
Okay, it's about the legs and the hypotenuse. What else about them? Look at the identities themselves. What's the Pythagorean theorem? Tell me. A squared plus B squared equals C squared. What do you notice about these identities? They all have squares in them, right? Your Pythagorean identities all have squares. What we're moving towards, we're not doing this today, but we're moving towards verifying trig identities, which is like a geometric proof, but with trig identities. And we're then going to solve. We're going to use these identities. What you guys need to be able to do with these, and we're going to do some math with it here in a second, but you need to be able to algebraically manipulate them. So if I have sine squared plus cosine squared equals 1. You guys will commit that to memory soon. You'll hear it 1,000 times. Say I want to solve for cosine squared. I wanted to say cosine squared equals. What could I do? Algebraically, what could I do? I could subtract sine squared from both sides, right? What you do to one side of an equation, guys, you do to the other, even though there's words and stuff in it. So you could rewrite this as cosine squared theta equals 1 minus sine squared, right? You need to be able to algebraically manipulate. Can I say that tangent squared is the same as secant squared minus 1? Look at the second identity.
Yes.
Can I say tangent squared is the same as secant squared minus 1? Yeah, because I move one to the other side. Look at the third one. Can I say cotangent squared is the same as cosecant squared minus 1? Okay, so you just need to be able to manipulate. Over here, these are called quotient identities. You guys don't have to know these right now. But you do, we're going to use this in 5.3 and 5.4. It's not going to be on the quiz. But we're introducing this stuff now because you're going to start to see it a lot. Think. Because we're going to talk about stuff that's on the unit circle when your R value is 1. What is tangent? What's our ratio for tangent?
Opposite over adjacent.
Opposite over adjacent. Okay. What are we, if we use x, y, and r, what is it? Y over x. What is sine? It's y over r. What's cosine? X over r. This is y over r. If you were to divide those two, it would be y over r times r over x, right? This will cancel. You get y over x. That's where these two things, sine divided by cosine, is always going to give you tangent. And then cosine over sine is going to give you cotangent. You will start to use those things in a little bit. Not right now. What I need you guys to do is write this down. This is going to be very, very, very useful to you for the rest of this chapter. You're going to see this in every single math class you take from now on. This tells you all you need to know about the signs of trig functions in the given quadrants. All right? The acronym that the book will tell you is all students take calculus. Think about that. All students take calculus. So all students, Alec, take calculus. All students take calculus. What does that mean? Alec's like, what does that mean? Okay, well, think about it. The word all. In the first quadrant, guys, what are the signs of x and y? Plus, plus, right? So in the first quadrant, all 6 trig functions are what? Positive. Because your x and your y are positive. So in the first quadrant, all 6 trig functions are positive. You'll see why this is so important in a little bit. So in the second quadrant, tell me about the signs in the second quadrant. X is negative and y is, why did I write a y? Y is positive. What trig function starts with the letter S? Sine. So in the second quadrant, sine and its reciprocal. What's its reciprocal? Cosecant. Good. In the second quadrant, sine and cosecant are positive. What's everything else? Negative. Tangent, cotangent, secant and secant and cosine and secant. In the third quadrant, guys, what are the signs in the third quadrant? Negative, negative, okay? So let's think about this for a second. What trig function and its reciprocal do you think are positive in the third quadrant? Tangent and cotangent. Tangent and its reciprocal. They are positive. Everything else is tangent and cotangent. It's the trig function and its reciprocal. Where you guys will get tripped up is they'll tell you the tangent of theta is like 4/3. And you guys are like, oh, sweet. What's your x? What's your y? This is y over x, right? So you'll tell me that it's 4,3. But then they might say the angle lies in the third quadrant. What does that matter? They're both negative. This is a negative x and a negative y. But the tangent's positive because what happens when you put a negative over a negative? You get a positive. That's why it is so important, guys, for you to know in each quadrant what the signs are for our x and y. In the fourth quadrant, what do you think is positive? The trig function. Cosine and its reciprocal of secant. Those are positive. What are the signs here for x and y? Plus and minus. So they're going to sometimes tell you, I'll show you 2 different ways, what quadrant the angle lies in. And you're like, why does that matter? Well, that matters because that associates a negative with the x value, the y value, with both of them or with neither of them. So it's really important to know what quadrant your trig functions are positive, where they're negative, and what the signs are, x and y, in each quadrant. Yeah.
What does
In the first quadrant, all 6 are positive because the x value and the y value in the first quadrant are positive. All right, so let's move along. I'm going to show you guys how to solve these problems 2 ways. If it just says solve, do what you want. If the question says to solve using the Pythagorean identities, then what do you have to use? The Pythagorean identities, the sine squared, the cotangent squared, whatever. All right, everybody with me? We okay? Find sine and cosine if tangent is 4/3 and is in the third quadrant. All right, how are we going to start this? First of all, it says to use the Pythagorean identity. So look at your identities. Which one has sine and cosine? The first one. Okay, so I'm going to write down sine squared theta plus cosine squared theta equals 1. You guys with me? Everybody with me? Okay. Now, I'm going to show you how to solve this, and then you're going to prove it using the identities. Let's draw a little picture here. There's actually two ways I could do this. Actually, no, we're going to leave it like that. Okay, I'll show you how to check it here in a second. What's another identity that I could use to solve this? Look at your identities, because they didn't give me sine or cosine. I'm going to have to use that formula in a second, but what's another one I could use? No, the Pythagorean identities, it says. Okay, tangent squared plus 1 equals secant squared. You guys agree? Okay. So what is the tangent? 4/3. I'm going to square it. Plus 1 equals secant squared. When I square 4/3, what do I get? 16/9. Are you guys okay with me changing 1 to 9/9? Okay. Equals secant squared. What's 16 plus 9? Okay, so 25/9 equals secant squared. I don't want secant squared, I want what? Regular secant. So I'm going to take the square root of both sides. So secant theta equals plus or minus what? 5/3. Okay, why is that helpful that I just found secant? Well, hold on, I can't plug it into sine squared, cosine squared. It's the reciprocal. If secant is 5/3, then what is cosine? Okay, so cosine of theta is plus or minus 3/5. But wait, is it plus or minus? Ooh, I like that. What quadrant is this angle in? It's in the third. What do I know about cosine in the third quadrant?
Why is cosine just sec of, oh wait.
The reciprocals.
Oh yeah, I just realized.
So what do I know? What is positive over here in the third quadrant? Tangent and cotangent. So what do I know about cosine in the third quadrant? It's negative. So your cosine, guys, is negative 3/5, right? So can I now take this and plug it in here and figure out what sine squared is? Yeah. I can say, okay, sine squared theta plus, instead of cosine squared, what am I writing? Negative 3/5 squared equals 1. So sine squared theta plus 9/25 equals, can I change that to 25/25? Okay. Now I'm going to subtract from both sides. So sine squared theta equals, what's 25 minus 9? Perfect. And then I take the square root. So I get the sine of theta equals plus or minus 4/5. Well, which one is it? Is it plus or is it minus? Why is it minus? Because we're in the third quadrant. Perfect.
Why is it 3/5 negative?
Because the angle is in the third quadrant.
Oh, right.
So that makes your x value and your y value negative. So that's how you would solve, guys, using the identities. You're just going to plug in values and algebraically work it out. But how could we check? How could we check? Anybody have, no, not even like that. Before, without using an identity, how could we figure that out? What did they give me initially? They told me the tangent. They told me the tangent of theta is what? 4/3? Correct? So what is that? 4/3, tangent. Okay, so they told me that x equals 3. They told me y equals 4. What else did they tell me about the x and the y? Why do you know that? Because it's in the third quadrant. Could you somehow figure out what the r value is? How? 3 squared plus 4 squared equals, what's r? No, r squared is 25. What's r? 5. Could you now have just figured out what the cosine and the sine and all that stuff is? Yeah, because what would cosine be here? Cosine is whatever what? No. X over R. So what would it be? Negative 3/5. What would sine be? Which is? Negative 4/5. So if you want to do that to check, you're well within your rights. But if it tells you you have to use the Pythagorean identities, then you have to do that. If I were you, I would do what I just did. Find the X, Y, and R. Find the answer, and then use that as a guide to go backwards. Let's look at the next one. What Pythagorean identity am I going to use for this one? It has cosecant and it has cotangent.
1 plus cotangent.
Perfect. 1 plus cotangent squared equals cosecant squared. All right, so what did they give me? Did they give me the cotangent? Yes, so I have 1 plus, I'm going to take negative 1/2 and do what to it? Square it, and that's going to give me the cosecant squared. Guys, when you square negative 1/2, what do you get? Good. Can I change positive 1 to 4 over 4? Okay, so this becomes 5/4, right? Equals cosecant squared. So how do I figure out what cosecant is? Take the square root. So cosecant theta equals plus or minus what? The square root of 5 over 2. Now, I'm trying to find cosecant. I'm almost there. But I don't know if it's positive or if it's negative. Did they give me any information that could help me out there? Where does the angle lie? In the fourth quadrant, all right? What do we know about the fourth quadrant? Y is negative, right? You have X is positive, Y is negative. What else do you know about the fourth quadrant? What trig functions are positive? Cosine and the secant. Is this cosine or secant? No. So what is this answer? It's negative square root of 5 over 2. What is the ratio for cosecant? Cosecant goes with sine. So it's R over Y. Your R value is always what? Positive. If you're in the fourth quadrant, guys, what is your Y value? Negative. If you guys know what the signs are in each quadrant, positive, positive, negative, positive, if you know the signs of X and Y, and you know which trig functions are positive and which are negative, you can very easily figure this out. Now, if this was just given to you and you weren't asked to use the Pythagorean identities, if they tell me the cotangent of theta is negative 1/2, right? What are they telling you with cotangent? What over what? What's cotangent? X over Y. Perfect. So I know my X value is 1. I know my Y value is 2. How do I know where the negative goes? Why is it the Y? Because the angle is in the fourth quadrant. In the fourth quadrant, the X value is positive, the Y value is negative. So could you easily find R here, guys? Yes. It's 1 squared, which is 1, plus what? 2 squared, which is 4, so I get 5. What's my R value? If R squared is 5, what's my R? Square root of 5. So now if you were asked to find any of the trig functions, could you just do it really easily right there? Yeah. So if you're asked to use the identities, you have to use the identities. But if they don't tell you to, find X, Y, and R, and then figure out what quadrant it lies in so you know if X is negative, if Y is negative, that sort of thing. And remember, R is always, 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 always what? Positive. Okay, good. There's going to be a bunch, you guys, some of you are going to see things differently, and that's totally fine. There's a lot of different ways to arrive at the same answer for this kind of stuff. And I actually think it's fun. I know you guys don't. You think I'm a weirdo, but that's fine. All right, find the value of the 6 trig functions of an angle in standard position running through about, do they tell me to do anything with an identity or anything? No. I personally would draw a picture first, but if you don't, it's no big deal. What did they give you here? They gave me an ordered pair. That's a lot of information. What 2 letters did they give me? X and Y. So you could say X equals negative 4, Y equals 0. So can you figure out what R is? How would you figure that out? Negative 4 squared plus 0 squared equals what? R squared. What's negative 4 squared? Plus 0. So 16 equals R squared. What's R? 4. Now, can you take that and find all the trig functions? Yeah, absolutely. But let me show you what this looks like. Let's understand, visualize this. It says the angle starts in standard position, which is right here on the x-axis, and it runs through the point right here. That means its terminal side, where it ends, is right here. What is this angle? If it starts here and ends here? 180. What is the ordered pair over here, guys, at 180? No. On our quadrants. Which way did you move? Left. Is that negative or positive? Negative 1, comma, how much did you move up or down? 0. Up here at 90, what's the ordered pair? 0, 1, good. Over here at 0, 360, what's the ordered pair? 1, 0 on our quadrant angles. And then what's down here? 0, negative 1. You guys you'll commit that to memory. Your quadrant angles are really important for you guys to memorize. So in either case, you guys could use this or you could use this and your answers will be the same. Because you're using the same sort of information. You're using the same, you're using the terminal side of the angle. But if we were going to do this, let's write all of our trig functions out. Every single time, rewrite. Then it gets committed to your brains. What's the opposite or what's the reciprocal of sine? Cosecant. Good. It would make sense if it was secant. So that's why you got to remember it's not. Doesn't make sense. What is the reciprocal of cosine? Secant. Perfect. And then tangent, cotangent is always easy. Tangent and cotangent. So let's talk about what the trig ratios are. What are the trig ratios for sine and cosecant? What over what? Y over R and R over Y. What about cosine? X over R and R over X. And then tangent. Perfect. Y over X and X over Y. So with our information, let's figure out what these values are. Y over R. Put Y over R. What do you get? 0 over 4. What's 0 over 4? 0. If you use the ordered pair here of negative 1, 0, you would put 0 over negative 1 and still get what? 0. Okay? So let's come over here. Cosine. What's our cosine? X over R? Negative 4 over 4, which is negative 1. Okay? Tangent. Y over X. What over what? 0 over negative 4, which gives you 0. So now when we flip to do our reciprocals, R over Y, it's going to be 4 over 0, which gives me no solution, undefined. Good. You can write undefined, you can write the null set, whatever. What about if I flip? I have 4 over negative 4, which gives me negative 1. Good. And then I flip, I have negative 4 over 0, which gives me undefined, no solution. If they give you an ordered pair, guys, they're giving you so much information. They're giving you the X value, the Y value. You could easily find the R. They're telling you where the angle lies, whether it's on a quadrant angle or if it's in a specific quadrant. And then you know stuff about the trig functions. All right, the next part is going to be easier now that we just went through all that. You initially look at this and you're like, what in the world? All right, let's think about this for a second. It says the secant of 180. What is the ordered pair? We just talked about this, and you guys are going to commit this to memory, I know. But what is the ordered pair at 180? Write that down. It's negative 1, comma 0. And I, as well, will write an X over the first one and a Y over the second, just so I don't make a silly mistake. What else did they tell me? Secant. Secant goes with which trig function? Cosine, okay? So cosine is what over what? X over R. So what are they asking me to find? R over X, okay. Now let's scoot over here. Just kind of write down some information. What is the ordered pair at 0, 360? 1, comma 0. Okay, this is my X, this is my Y. And what's the trig ratio for tangent? Y over X, okay? So all this is saying is you're going to take the whole number 3 and you're going to times it by the secant of 180. So the secant of 180. If we're on the unit circle, if we're on a quadrant angle, your R value is always 1. If you guys are like, how do you know that? Is that always true? Work it out. What's negative 1 squared plus 0 squared equals R squared? What's negative 1 squared? 1. What's 0 squared? 0. So 1 equals R squared. So what's your R value? 1. So when I take my X value, negative 1, and I put it over R, that's what I get right there. Now I'm going to say minus 5 times your tangent. Take the Y, which is, what's the Y of 360? 0 over 1. So if you multiply 3 times negative 1, what do you get? Negative 3 minus, what's 5 times 0? 0. So what's my answer here? That's it. If you guys know these trig ratios, your life's going to be so much easier. Yes, sir?
So no calculator?
I have absolutely, well, yeah, on the quiz, you're going to have a calculator.
Okay.
Because you're going to have to find the degrees, minutes, seconds, all that. But you have to, like this is what needs to be shown. All right, let's go through this. Just think about this for a second. What's tangent, guys? What over what? Y over X, great. And what's the ordered pair at 0, 360? 1, comma 0, perfect, okay? So sine is what over what? Y over R. And what's the ordered pair at 180? Negative 1, 0, perfect. This one says cosine squared, no big deal. We know how to square numbers. What's cosine? X over R. And what is the, why did I write that? What is the ordered pair at 180 again? Negative 1, 0. So let's just write what we have here. Tangent is Y over X. So I'm going to say 0 over 1. You guys with me? Plus 4 times sine is what over what? Y over R. So my Y is 0. Since I'm on a quadrant, what do I know my R value is? Positive what? 1. Good. If it's on the quadrants, yeah. Because when you work it out, think about it. If you take negative 1 squared plus 0 squared, you get 1. And then you take the square root, you get 1. And then the last one, it says plus 2 times, what's cosine? What over what? X over R. So what's your X value? Negative 1 over 1. And you have to square that. So guys, what's 0 over 1? Okay. What's 4 times 0? And then what's negative 1 squared? 1 times 2 is 2. So what's your answer here? 2. Take a picture of this. Take a picture, take a picture, take a picture. Real quick, and then we're done. You guys are going to get questions like this. You are going to see this as we move through this trig unit. And I want you to understand how helpful it is to know what's going on where in your quadrants. So important. We know that if they tell you the angle lies in quadrant 2, you know that X is negative, Y is positive. If they tell you the angle lies in quadrant 1, you know X and Y are both what? X and Y in quadrant 1, positive. If they tell you quadrant 3, you know X and Y are what? Both negative, all right? Sometimes, though, they don't tell you it lies in this specific quadrant. They'll give you something like this. So I want you guys to understand, these are called parameters. You are going to use these parameters, and you're all students take calculus. You use each parameter separately. You deal with it first, the first one given, then you deal with the second one. Let me show you what I mean by that. So this first thing says sine is greater than 0. What does that mean? Is it positive or negative? Positive. So let's look at our all students take calculus. What two quadrants, it's always going to be 2. What 2 quadrants is sign positive? A and S, correct? First and second. So this angle cannot be in the 3rd quadrant and it cannot be in the 4th quadrant. So now your second parameter says, okay, with the 2 that are left over, the cosine is positive. So with what's left over, where is cosine positive? In the 1st quadrant. So where does this angle lie? In quadrant 1. So what is that telling you about whatever x and y value you have? They're both positive. It's very important that you guys can reason through this. Now let's look at the next one. Okay, again, all students take calculus. You look at each parameter separately. Look at the first one. Whenever I have a reciprocal function, I always write the original so I don't make a silly mistake. What does secant go with? Cosine, all right? So it says cosine is less than 0. What does that mean? Negative, okay? In all students take calculus, where is cosine and secant negative? Here and here. How come you guys didn't say the first one? Because everything's positive. Good. How come you didn't say the 4th one? Because that's where cosine and its reciprocal are positive. Good. You'll always be able to cross off 2 with the first parameter, and then you can narrow it down to the right or wrong with the second parameter. The second parameter says tangent is greater than 0. What does that mean? Tangent is what? Positive. With what you have left over, guys, where is tangent positive? In the 3rd quadrant. Tangent is positive in the 3rd quadrant. So what information did they just tell you about your x value and your y value? They're both negative. Because you guys aren't going to make mistakes with the math. You guys are going to get square root of 5 over 2. But some of you are going to make a mistake and say it's positive when it should be negative because you don't know what quadrant the angle is in. That's what you guys really, really have to focus on. All right? Your homework, we moved the due date to Monday. So you guys have until Monday to submit the homework. Don't wait to do it until then. Tomorrow in class, I'll answer any questions you have about the homework. We'll start going over the quiz review. Monday, we're going to review a little more. Tuesday, if you are a junior, you have the ACT. If you are a 10th grader or a 9th grader, you have the pre-SAT, I think they call it, right? ACT? It's the pre. Huh? It's the PACT. It's like the practice one. So you got, I'm not going to, I mean, I might see you, but we don't have class that day. So your quiz will be on Wednesday. We have not made it. We haven't even talked about it. Miss Corey's out sick, so I'm not exactly sure what it's going to look like, but I'll have more information for you there tomorrow on Monday. Great job today.